This is the fourth and final video accompanying the session notes for the Further Mathematics conference session, Getting a Feel for Further Mechanics. In this final video, we will look at where these ideas can be taken next. To begin with, let's look at what happens when a ball collides with a fixed surface. As an example, let's take the coefficient of restitution to be equal to 0.5. If a ball approaches a fixed surface at right angles with a speed of 10 meters per second, then the coefficient of restitution tells us that it would then rebound in the opposite direction with half the speed of 5, here because e is 0.5 and 10 multiplied by 0.5 gives me 5. Where an object does not collide perfectly at right angles to the surface, we would describe this as an oblique collision. Here, we need to take into account the fact that the impulse created by the wall will act at right angles to the wall itself. In other words, only the velocity component perpendicular to the wall will change. So if we have a ball approaching the wall with the velocity components 4 and minus 4, then after the collision, assuming that e remains as 0.5, the horizontal component of the velocity will also still be 4. However, the vertical component has now changed. It has changed sign because it has changed direction, and it is also halved because of the value of e. Let's now link all this back to projectiles where we started. Consider this case. The ball is projected horizontally from a fixed height, just as it was in the very first question, but now we want to consider what will happen after it hits the ground. This is a case of what happens next in two senses. What happens next to the ball, but also what happens next in terms of our mechanics journey and applying the ideas that we've been looking at. We could challenge students to predict what the subsequent path of the ball would look like. They can probably sketch freehand roughly what it would be, but we can challenge them to add as much detail as possible. For example, if we knew the value of e, the coefficient of restitution between the ball and the ground, would they be able to predict subsequent heights of each subsequent bounce? We could ask many further questions. Here are some suggestions. We could consider the specific cases of 0 or 1 and ask students to write in detail what would happen to the path of the ball following the first impact. We could discuss the different factors involved and which of them has the biggest effect on what the subsequent motion would look like. And possibly even some more advanced questions, such as exploring the angle between the ball and the ground after each successive impact. Could students, for example, form a sequence of showing how the angle would change with each successive bounce? For all of these, there's plenty of work to be done on exploring modelling assumptions and the effect that they might have. And this sort of high-level thinking will help prepare students for more complicated exam questions of a problem-solving nature.